The length of each side of the cube is x. So a cube is three-dimensional. This length here is x. This length here is x. And this length here is x as well. Write a function to describe the volume of the cube. So it says a function. Functions start with f, so common is f of x equals, well, because it's three-dimensional, I have x to the third power, or that's what they call it, cubic. Raise your hand if you got that. Complete a table of values for the volume function. So here is a table of values. It's this thing right here. So I'm just going to go ahead and pick some numbers. Again, this is a test-taking strategy that might have to use not only for this class, but for higher level like ACTs or SATs, entrance exams. So I'm going to start at -2. You always want to pick negative numbers, include 0, and then the positive numbers. Class, what's -2 times -2 times -2? Negative what? Class, what's -1 times -1 times -1? Now, if you get stuck on that, calculator. Remember the negative sign on your calculator is down here. Both for a scientific and a graphing calculator, this is subtraction, so there's a difference. So I'm putting in -1 caret third power gives you -1. You can also do -1 times -1 times -1. 0 to the third power, class? 1 to the third power? 1 and 2 to the third power? 8. Alright, let's go ahead and graph these. I did not draw a really good graph, so let's count by 2's here. So I'm going to write down my graph, 2, positive 2, so -2, -8, -2, -4, -6, -8, -1, 1, so that would be a half on mine, because remember each box is worth 2. 0, 0, 1, 1, so half, half, and then 2, 8. Right 2, so that's 2, and then 2, 4, 6, 8. What portions of the graph represent the length of a side of a cube and the volume of the cube? So here's my cube. That means that all of the x values, just one x value, all of this right here, that is the length of the side of a cube. Length of side of cube. That's what x represents. Now, can we have negative values? Can you have a negative length here? No. Only the positive x values represent the length of the side. Now the volume of the cube represents everything over here, right? Because remember, volume represents length times width times height. But the difference about this problem x is that in a cube, they're all the same equal distance. So volume equals x times x, which gives us x to the third. Now if you think about it, can you have a -8 volume? No. So only the positive y values. So let's write that. Volume of cube. Only the positive y values represent the volume of the cube. So in graphing this, you can get a cubic function. You can always get values, but when we put in a real-world context of a cube, we're only focusing on the positive values.